Today we are going to discuss heap. Now what is a heap? Heap is a special kind of a complete binary tree. There are two kinds of heap. One is max heap, another one is mean heap. Now what is the speciality of a max heap? If there is a node X, then all the nodes, whether it is the left child or the right child, the left child or the right child, both would be less than X. That means the parent has to be more than both of its children. So suppose I have got 40 as my root node, then the node on the left hand side of 40 should be less than 40. Node on the right hand side of 40 should also be less than 40. So suppose there we can have a node like this 32. Over here we can have a node like 38. Correct? So all the nodes on the left hand side and right hand side of the parent node should be less than the value of the parent node. Again, the child, that means this 32, the node bearing 32 should also be a max heap, should have the condition of should follow the condition of the max heap. That means all the node on the left hand side of 32 should be less than 32, and all the nodes on the right hand side of 32 should be less than 32. So suppose we have 30, 31. Correct? Both are less than 32. So this is allowed. 38. All the nodes on the left and the right side of 38 should be less than 38. So all the child nodes should have value which is less than the parent node. So suppose the node is 25 and this node is suppose 35. So you see 25, 35 both are less than 38. So this is allowed. Clear? Now coming to mean heap. Mean heap is just the opposite of max heap. That means if the parent node is X, then both the child node should have values which are greater than X. Both the left and the right child should have values which are greater than X. So if this node is 40, then left hand side of 40 should also have a value which is greater than 40, and right hand side should also have a value which is greater than 40. So suppose 50 and 60. So 50 and 60 both are greater than 40, so they can be the child nodes of 40. Again, left and the right child nodes of 50 should have values which is greater than 50. So let it be 55 and 65. So both are greater than 50, so it is allowed. And all the left and the right child node of 60 should have values which is greater than 60. So suppose 61 and 70. So 61, 70 both are greater than 60. So this is allowed. So max heap parent value should always be greater than the values borne by the children, and in mean heap the value of the parent should always be less than the value of the child nodes. Right? Now let us see how we can insert a node in a heap. Suppose we want to insert these nodes in a heap and we want to create a max heap. Correct? So we want to insert these nodes in a heap and we want to create a max heap. So 20, it is the first node that is to be inserted. Fine. Now after 20, 25. Now heap is a complete binary tree. So we know that in a complete binary tree, the left children or left child node has to be populated first, correct? So 25 will become the left child of 20. Until and unless a node has a left child, you cannot put a node in its right child. That is the rule of a complete binary tree. So 25 has to be the child node. Now if you look at the tree, it is a max heap. So what is the max rule of a max heap? The parent node should have the value greater than the child nodes. So over here, parent node value is 20 and child node value is 25. So this is not as per the rule of max heap. So therefore, the values will be swapped. So 25 will become the root node and 20 would become the child node, right? Because this 25 being child of 20 does not cater to the rule of a max heap. Clear? Then comes 19. So going forward with the rule of complete binary tree, 19 should become the right child of 25. Now when 19 becomes right child of 25, if we look at this tree, 20 and 19 both have values which is less than 25. So it is catering to the rule of complete binary tree. So this is fine. Then comes the node 10. So according to the rule of complete binary tree, we should always start inserting from the left hand side. So 10 would become the left child of 20 according to the rule of complete binary tree. Now if we look at the tree, 10 child of 20 has value less than 20. 20 and 19 children of 25 has value less than 25. So this is a max heap. Then comes the value 15. 15 will become the right child of 20 according to the rule of complete binary tree. So again if we compare, we find that 10 and 15 both have values which is less than 20. 20 and 19 both have values which is less than 25. Clear? So this is also fine. Now comes to the value of 23. So over here we have got 25, 20 and 19 as the two children. We have got 10 and 15 and 23. So according to the rule of complete binary tree, 23 will become the left child of 19. Now if we look at the tree, 10 and 15 both have values which is less than 20. Over here there is 23, but 23 is greater than 19. So this is not allowed in a max heap. 23 child of 19 not allowed in max heap. So we have to swap these two numbers. So this tree would become 25, 20, 10, 15, 23 and left child of 23 is 19. Clear? Now you should not stop here. Before we proceed, it should also be compared whether 20 and 23 both are less than 25. So you see 23 is the newly inserted node. 23 is the newly inserted node. Before 23 was inserted, the tree was a perfect max heap, correct? So we can actually leave out this part of the tree because this part of the tree was also present in the previous tree. So this part of the tree has already been taken care of, and this part of the tree, that means the left subtree, already existed in the previous case. So This is absolutely fine. What we have to check is with the newly inserted node. So what is actually the case? We have to check. We have to start with the newly inserted node, and we have to go absolutely till the root to find that the newly inserted node actually caters to the rule of Max Heap. Correct? So the we should follow the path of the newly inserted node and find out and verify or validate that newly inserted node is not hampering the Max Heap condition of the tree. Clear? Now next node 2. So over here 2 will be inserted. As 2 gets inserted, we find that it is catering to the full Max Heap, because 10 and 15 both are less than 20, 19 and 2 both are less than 23, 20 and 23 both are less than 25. Last number is 9. 9 will be inserted over here, and it will cater with the rule of the Max Heap. Now let us, just for the sake of understanding, let us insert a number 30 in the heap. Now when we insert 30 in this tree, 30 would be inserted as the right child of 10. Now this will not be a Max Heap. So see, 9 was already present in the previous case. So we need not compare the tree with 9. We have to only consider the newly inserted node. Now when we consider the newly inserted node, we see that 30 is greater than 10, so it is not allowed. So we have to swap the two values, and we would get a tree which looks like this. Correct? Now after this swap, we have to check whether 30 and 15 both are less than 20, but over here we see 30 is greater than 20, which is again it is not a Max Heap condition. So again we have to swap these two numbers, right? So as we swap these two numbers, so the tree looks like this. Now once 20 and 30 has been swapped, we have to check whether 30 is lesser than its parent, newly acquired parent. But over here we find that 30 is greater than 25 as well. So again we have to swap these two nodes. So the tree will become 30, 25, 23, 20, 15, 9, 10, 19 and 2. So therefore you see, when we are inserting a node in a heap, we have to insert the node in the leaf. Whenever we are inserting a node in the heap, we are always inserting the node as the heap node, and then the node inserted is making its way through its parent nodes to its correct position. Correct? So we are inserting the new node as a leaf node, and then the leaf node is following the path of its parent to get its proper position in the heap. So that is how a node in the heap is inserted. Let's discuss the concept of heap sort. I have already told you what is a heap and how heap can be created. Now this is an array of 8 numbers. Let us call this array as X. And there are 8 numbers in the array, and we have to sort this array in ascending order, right? So how do we do that? To sort this array in ascending order, we are going to sort it in ascending order. To sort this is in ascending order, we are going to create a max heap out of this array. To sort this array in ascending order, we will be creating a max heap out of this array. Correct? Now I have already told you how a heap is created. What is a max heap? We know a max heap is a heap where the parent node is always greater than the child nodes, right? And how a heap is created, that has already been discussed. Now, first step is to create a heap out of this array. To create a heap out of this array, what we have to understand is linearization of a tree, which I have already discussed with you. What is a linearization of the tree? Linearization of the tree tells you that if a parent node is at a 0th position, then the left child of that node is at 2 into 0 plus 1th index, and the right child is at 0 into 2 plus 2th index. I will simplify this for you. This is the array, and if this is the array and we are to create a tree out of this array, then the tree would look like this. Right? This 20 is at 0th index, 19 is at index number 1, 35 is index number 2, 1 is at index number 3, 44 is at index number 4, 93 at index number 5, 18 has index number 6, and 24 has index number 7. Now if the parent is at index number say I, then the left child would be at index number 2 into I plus 1, and the right child would be at index 2 into I plus 2. This linearization of array I have already discussed with you, right? So that concept of linearization is to be used to create a heap out of this array, right? Now we would start from the very end. We will not start from the beginning of the array. We would start from the very end of the array, and we would create a heap out of this array. Correct? Now if we create a tree from this array, this tree would look like this. Correct? But though this is a binary tree and a complete binary tree, this is not a max heap. So we have to rearrange the numbers in this tree to create max heap. And from where we would start creating the max heap, as I have already told you, we will start from the very end of the array. That means we will start from the leaf node of the tree. Now what would we do? We will take the number 24 and its sibling. Over here the sibling of 24 is null and the parent. So we will take these 3 nodes and we will see which is the maximum value in these 3 nodes. Now in these 3 nodes the maximum value is 24. So the parent is lesser than 24. So this is not actually it is not maintaining the rule of the max heap. So we will swap these 2 numbers, and after swapping we will get the tree which would look like this. Okay. Now, after this, we will go to 93, 18 and 35. See, this was your 7th index. Now we will consider the 5th index and the 6th index and the parent. 5th index and the 6th index and the parent. So we will check out of these 3 nodes which is the maximum node. The maximum node out of these 3 nodes is 93. So again the parent is smaller than 93. So therefore we will again have to swap to create to bring it closer to a max heap. So the tree would look like this. The left child of 93 will become 35, right child is 18, 24, 44 and 1. Now, in normal case, we should not stop over here. Once we have swapped 93 and 35, once there has been a change made, we will check whether the place where we have swapped, that means 93 was at this position, at the 5th position, which has been interchanged by its parent node, correct? So we will check whether this 35 has got child node. If 35 has got child node, whether this 35 has got any child nodes. If the 35 has got any child nodes, then we have to recheck whether it maintains the concept of max heap or not. For this example, 35 does not have any child, so there is no need for any re-verification. Right? Now we come to this part. 24, 44 and 19. So we will check whether these 3 nodes cater to the concept of max heap. But we find again that 24 and 44 is greater than 19. That means it is again violating the concept of max heap. So again we will search for the maximum. So maximum over here is 44. So 19 would be swapped with 44. And the tree would look like this. 19 would become the right child of 44, 24 would come on the left, 93 will have 35 as its left child, 18 as its right child, and 1 will be on the left of 24. Now, as I already told you in this previous case, again, since 44 has got swapped with 19, so we will check this position, the position with which we have replaced its parent. So we will check the position, that means this position at 19, to check whether it has got any children, and if it has children, whether it is again catering to the concept of max heap. But over here again 19 does not have any child node, so again that is not required. After taking care of this level of the tree, we will come to the next level, the previous level, 44, 93 and 20. So we will see whether these 3 nodes are creating a max heap. But again we find that 44 and 93, they are greater than 20, so again it is violating the concept of max heap. So again we will search for the maximum of these 3, that is 93, and replace the root node with 93. So 93 would be swapped with 20. So we will get the tree as 93, 44 as the left child, 20 as the right child, 24 and 19 children of 44, 35 and 18 children of 20, and 1 as child of 24. Now again, as I have discussed in the previous case, 93 was at this position which got replaced by its parent. So we will check the value at this position again to re-verify that it caters to the concept of max heap. But over here, when we try to verify, we see that 20 has its child as 35 and 18, and out of these three nodes, there 20 has got a child which is greater than 20. That means 35 which is greater than 20. So we again have to swap. So it will become 93, 44 and 35 as children of 93, 24 and 19 as children of 44, 20 and 18 as children of 35 and 1. Now we swapped the number over here with the parent with the child at this position, correct? So again we have to re-verify that this position also does not violate the concept of max heap, but 20 does not have any children right at this moment, so further re-verification is not required. So you see, we had this array and we created this max heap out of this array. This is a max heap that has been created out of this array. Now what is basically the concept when we are sorting using max heap? The concept when we are swapping using max heap is that when max heap gets created, the highest number in the array becomes the root node. When the max heap gets created, the highest number in the array becomes the root node of the max heap, pertaining the concept of max heap, correct? So this root node is then replaced with the last leaf node. The root node is then replaced with the last leaf node. So we will replace this 1 over here with 93. So we will swap the 1 with 93. So we will have a tree which would look like this. The tree would look like this. 1 would go up and 93 will come down and become a leaf node, right? So you see, as I told you in the previous case, this 1 is the 7th index, right? That is the last index of the array. Now 93 has become the 7th index of the array. So 93, which is the largest number, has been placed at the end of the array. This was our initial array, and after creation of the heap and replacing the maximum number with the leaf node, we have got this array, this arrangement of the array where the maximum number in the array has been placed at the end. So the number which was the maximum number in the array has got its position in the array, correct? So now the concept is we would leave this number because this number has already got its correct position in the array. We will leave this number and we will again create heap out of these remaining numbers, right? So the heap was looking like this. After 93 was replaced with 1, the heap was looking like this. So we will leave this number 93 because 93 has already got its correct position in the sorted array. So we will leave 93 as it is, and with the remaining 6 numbers we will again start off with our heap. Correct? So this was the current, it was the scenario. So again we will start from the beginning of the array now. 0th is the root node, so we will start with 1 and we will check whether 1 and its children follows the rule of heap, max heap. But we find over here that 1, 44 and 35 is violating the rule of max heap. So again we will find the maximum amount amongst these 3 nodes. Maximum among these 3 nodes is 44, and so 1 will get replaced with 44. So we will have 44, 1, 35, 24 and 19 as children of 1, 20 and 18. Now since 1 and 44 got replaced, that means the node at this point got replaced with its parent. So we will find whether this is creating an heap, max heap. But again we find that over here it is violating the concept of max heap. So we will find the maximum in this 3 numbers. Maximum in these 3 numbers is 24, and we will replace 1 with 24. So the tree will become 44, 24, 35 as children of 44, 1, 19, 20, 18. Now over here again this position replaced its parent. So we will check whether this position and its children caters to the rule of max heap, but 1 does not have any child node, so the verification is not required. Now once this heap has been created, again we will find that the number which is the next maximum, 93 was maximum, the number which is next maximum number amongst the 6 numbers is again at the top. So this number root will be replaced by the last leaf. Now which is the last leaf? 18. So 44 would be replacing 18. So 18 will become the root, 24 and 35 would become its children, 1 and 19, 20 and 44. 44 would become the right child of 35. So therefore now the array would look like this: 18, 24, 35, 1, 19, 20, 44, and at the end 93 was there. So 93 has got its position, and if you see 44 has also got its position now, right? So again we will leave these 2 nodes and we will again start off with the heap for these 5 nodes. So 18, 24, 35, 1, 19 and 20. We will leave out 44 and 93 because that is already sorted. So again we will start with the root node, and again we will check whether the 3 nodes, that is root and its children, is creating a max heap. But again we will find that there is a violation. So we will replace the root with the maximum of the 2 children, that is 35. So 35 would replace 18 and it would become 35, 24, 18. Now 18 has replaced 35. That means node at this position has replaced its parent. So we will check whether node at this position and its children is creating a max heap. So we find that 18 has got only one child. The right child is null because we have not considered 44. So out of these three nodes, 20 is maximum. So 20 would be replacing 18. So the tree would become 35, 24, 20, 1, 19 and 18. After this, we will, since 18, that means node at this position has replaced its parent, we will check whether this caters to the whether 18 is creating a max heap with its children, but 18 does not have any child, so again verification is not needed. Clear? So now if we look at the heap, again 35, which is the next highest number, is at the root. So again 35 would be replacing the last leaf. So which is the last leaf? Again 18 is the last leaf. So 35 would be replacing 18. So the tree would become 18, 24, 20, 1, 19 and 35. So the array would become 18, 24, 20, 1, 19, 35, 44 and 93. Now 44 and 93 also already had its position, and now 35 has also got its position in the sorted list, right? So again we will continue with the heap with the remaining 5 numbers, 1, 2, 3, 4, 5, sorry, 5 numbers in the list, right? So the heap looks like this right at this moment. One, 19 and 35 we will not consider anymore because 35 has already got its position, correct? So now again we will start with the root node. Root node and its two children, we will see whether it is creating a heap. But again 24 is the maximum, so 18 would be replaced by 24. So the tree would become 24, 18, 20, 1 and 19. Now the node at this position has replaced its parent, so we will check whether the node that replaced its parent is pertaining to the rule of max heap. But again there is a violation, so 18 would be replaced by 19, right? So 24, 19, 1 and 18 and 20. So again as we see, 24 has got its position in the in the root of the tree. So now the array has become, now we will replace this 24 with 18. The last leaf of the tree is 18, so we will replace 24 with 18. So the tree would become 18, 19, 20, 1 and 24. And the array will become then 18, 19, 20, 1, 24, 35, 44, 93 has got their position, right? So you see this last 4 nodes have already been sorted. So again we will continue with the 4 nodes that are there. So 18, 19, 20 and 1. Again we will start with the root node and we will find out whether it is creating a heap. No max heap, it is not a max heap. So 18 will be replaced with 20, which is the maximum out of these 3. So 20, 19, 18 and 1. right? Now 18 has replaced its parent, so we have to re-verify whether 18 is creating a max heap with its children as well, but there are no children of 18, correct? So now 20 is at the root, so 20 would be replaced with its last leaf of the tree, which is 1. So 20 and 1 will be replaced, right? So it will be 1, 19, 18 and 20. So now the array will look like 1, 19, 18, 20, 24, 35, 44 and 93, correct? So now these 5 nodes has got its position. 1, 19 and 18, they are left in the tree. Again we will check whether these 3 are creating a max heap, but no. So 19 will replace 1 and 18. We have to check whether this node, which has replaced its parent node, has made max heap with its children, but 1 does not have any child, so we are good. Now 19 would be replacing the last leaf. Last leaf over here is 18. So 18 will move up and 1 will come down and 19 will become the right child. So it will become 18, 1, 19, 20, 24, 35, 44 and 93. So that will be the current array. So when we consider the current array, all these nodes have been sorted. So we are left with only 2 nodes, that is 18 and 1. Now you see, when we will be checking, it is already a heap, so there is no replacing of any of the nodes, so it will be 18. 18 will replace 1 because it will replace the last leaf. So the array will become 1, 18, 19, 20, 24, 35, 44 and 93. So we get a sorted list in the ascending order, correct? So let me go back from where we started. When we are sorting an array in ascending order, we use a max heap, right? Now we had started off by creating the max heap from the end. We started to create the max heap from the last of the array. That means first, when we had taken the tree into consideration, we started creating the heap from the end. But once the heap was created over here, after the list was heap was created and we got the first sorted number in the list, from then on we have always considered the heap from the root node. Again, I will repeat what I said. When we had the unsorted array, we got the tree from the array and we created the heap. When we started to create the heap, we created the heap from the last node. We considered the last node and then we moved up. And as we created the heap, we got the first sorted node or the first sorted number in the array. That is the last number in the array we got, right? Now after that, after getting the first sorted number of the list, when we started off with our second iteration, the second iteration started from the root node. We did not start the second iteration from the last node of the list. So therefore, to create the heap for the first time, we need to start from the end. But once the heap has been created, then we again continue from the root node of the tree. Correct? So this is how heap sort is done. When we are sorting the tree in ascending order, we use a max heap. If we are sorting the array in descending order, then we will be using a mean heap. And if we are using a mean heap in case of descending order sort, then the minimum number in the list will become the root node of the heap every time, and that minimum number will be placed at the end, and we will continue with the minimum heap creation. And as we go on creating the minimum heap, the bigger numbers will be placed in front of the smaller numbers, sorting the array in descending order. So for ascending order sorting, we will create max heap. For descending order sorting, we will create mean heap.